right, this video is over graphing reciprocal functions. Okay, the reciprocal parent function is f of x equals 1 over x. Okay, if you were to graph that on your graphing calculator, it would look kind of like this. You have points here, here, here. It's gonna look, this is not gonna be exact, but it's gonna look something kind of like this. Okay, and if you think back to Algebra 1 when we talked about inverse variation and the graph of that, that's what this is. It means the same thing, okay? This type of graph is called a hyperbola. Looks like that, okay? The domain for this is going to be, it has to do with asymptotes, okay? We've talked about asymptotes before, it's been a while, but remember asymptotes are the boundary lines. So the domain is whatever your vertical asymptote is. And so on this particular one right here, it's not going to include when x is 0. So you say x does not equal 0. The range, same thing, but it's going to be for the horizontal asymptote. And so in this case, it's going to be y does not equal 0. Okay, a vertical asymptote, or that goes with the domain. In this case, our vertical asymptote is x equals 0. And our horizontal asymptote is y equals 0. Okay, let's talk about standard form of a reciprocal function. This is f of x equals a over x minus h plus k. Okay, remember, all of this stuff still means the same thing we've been talking about on transformations all year. So the h stands for the horizontal shift. Okay, if it's positive, it shifts to the left. If it's negative, it shifts to the right. The k stands for the vertical shift. If it's positive, it shifts up. If it's negative, it shifts down. If a is negative, then the function is reflected across the x-axis. If your a is greater than 1, it represents a vertical stretch. And if it's in between 0 and 1, it represents a vertical compression. Okay, the vertical asymptote is going to be x equals the h, and then the horizontal asymptote is y equals the k. Okay, so writing functions, so it says the reciprocal parent function is reflected across the x-axis. Okay, so that means our a is going to be negative. Then it translated 4 units right, so that means it's going to be minus 4, and 3 units down, so it's going to be minus 3. Write an equation to represent the new function, identify the asymptotes. Okay, so that's going to be f of x equals, the only thing it said about the a is that it reflects, so that just means it's going to be a negative 1. And it's going to be x minus 4 since it shifted to the right 4, and minus 3 since it went down 3. And then to identify what the asymptotes are going to be, okay, well our asymptotes right here, our vertical asymptote is going to be x equals 4, and our horizontal asymptote is y equals negative 3. Number 2, the reciprocal parent function is vertically stretched by a factor of 2, so that means our a is 2. Then translated 7 units up, so it's going to be plus 7, and 1 unit left, so it's going to be plus 1. Write an equation to represent the new function, identify the asymptotes. So f of x equals 2 over x plus 1, and then plus 7. Our vertical asymptote is going to be x equals a negative 1. Our horizontal asymptote is y equals 7. Number 3, a reciprocal function has a vertical asymptote located at x equals negative 2, and a horizontal asymptote located at y equals 5. Write an equation that could represent this function. So this time we're working backwards. So the vertical asymptote is x equals -2, and the horizontal asymptote is y equals 5. So that means we don't know anything about the a, so we're just going to put 1. If this is -2, then that means that this is x plus 2, and this is plus 5. Okay, flip over to the other side. Now let's talk about the graphing part. So it says graph each function, identify the domain and range and symptoms, or I'm sorry, and asymptotes are the wrong thing. So right here, we can actually look at this to figure out, we can look at the equation to automatically figure out what a vertical asymptote and horizontal asymptote are going to be. So because there's not a number here with the x, and our vertical asymptote is just going to be x equals 0, our horizontal asymptote is going to be y equals -2. So let's start off by graphing that part. So x equals 0, that is on the y-axis. You're just going to draw a dotted line down. And y equals -2, draw a horizontal line right here. Okay, our domain, it's everything but what the vertical asymptote is. So x does not equal 0. Our range is everything but what the horizontal asymptote is. So y does not equal -2. Okay, so if you want to go get the points, you can, but all you really have to do is draw that, and then it's going to be something like this. As long as it's pretty close to it, then that's fine with me. Okay, all right, number 5. Our vertical asymptote, okay, so x equals -3. Our horizontal asymptote, there's not anything out there, so it's y equals 0. Okay, so that means our domain is x does not equal -3, and our range is y does not equal 0. Okay, so then we want to draw our asymptotes. So 3 right here, and y equals 0. Okay, and then it's going to look something like this. Something like that. Okay, all right, number 6. This one you actually probably want to figure out exactly what the points are, because it is going to change. We're going to actually have a vertical stretch on this because it's a 4, and it's also a reflection, so that means it's going to be in these 2 boxes right here. So our vertical asymptote is going to be x equals 0. That means our domain does not equal 0. And our horizontal asymptote is going to be y equals 1, so our range is y does not equal 1. Okay, so we have this. And this right here. Okay, our points on here, we're going to have -2, 3. 1, 2, 3, -4, 2. -1, 1, 2, 3, 4, 5. It's going to be something like that. Okay, and then same thing over here. We are going to have 2, -1, 1, 2, 3, 4, 0, and 1, -3. Like this. Okay, All right, number 7. Our vertical asymptote is going to be x equals 2, and our horizontal asymptote is y equals -2. So our domain is x does not equal 2, and our range is y does not equal -2. Okay, and then our points are going to be at 1, 2, 3, 1. At 1, 2, 3, 4. Well, hold on, let me top this in, because that one has a bunch of decimals. So 3. Okay, so it's 3 over x minus 2. And then minus 2. And table. It's a bunch of decimals. Let's see. We have -1, -3. We have 3, 1. I already have that. 1, -5. 5, -1. 1, 2, 3, 4, 5, -1. Okay, so that'll work right there. That's pretty close. Okay. All right, number 8. Vertical asymptote is x equals -4. So domain x does not equal -4. Our horizontal asymptote is y equals -7. Our range is y does not equal -7. So we have 1, 2, 3, 4. Vertical asymptote right here. Horizontal asymptote 1, 2, 3, 4, 5, 6, 7. All right, there. Okay, and then to get the points, I'm going to type that in. So let's see, we have 2 over x plus 4. And then minus 7. And we have -2, -6. We have -3, -5. -5, -9. -6, -8. And that's going to be pretty good. It's going to look something like that. Okay. All right. And then number 9. Vertical asymptote is x equals 5. So domain is x does not equal 5. And horizontal asymptote is y equals 3. So the range is y does not equal 3. So 1, 2, 3, 4, 5. And 1, 2, 3. And then type that in to get your points. So we have -1 over x minus 5, and then plus 3. And we have 4, 6, 2, the rest look like a bunch of decimals, so 5 over 2 is 2.5, so 7, 2.5, 1, 2, 3, 4, 5, 6, 7, 2.5, and 3.5. 1, 2, 3, 1, 2, 3.5. Okay, so it's gonna look something like this. Okay, there we go. All right, so this is graphing reciprocal functions.